For advanced F2L, it is really important that you solve cases efficiently. So for example, for this pair here, instead of breaking them up like this, which doesn't lead to a paired case, what you can do instead is to insert the corner in like this, and then pair them up, then insert. Now obviously that case that I just showed was just an example, and this idea can be used for different types of F2L cases. So last example was when the pieces were attached incorrectly. In this case, when we have the orange and blue and this edge is inserted incorrectly, then we can take the same idea. So if we just take the edge out in a random way, it doesn't lead to a paired F2L pair. Whereas if we're smart about how we take it out, we could, for example, use a sledgehammer to take the edge out. That leads to a paired up case where we can go straight into the insert. And this idea also extends to when the corner is in the incorrect slot and the edge is on the top layer. So once again, we don't want to take the corner out in any random way. In this case, it gave us a worse F2L case. So in this case, what we could do is take the corner out like this instead, and then go into the back slot. So once again, those were just a few examples of how to solve F2L cases efficiently. The general rule is that when you take pieces out of slots or when you break pieces up, you want to do so in a way that pairs them up so you can go straight into an insert. I have videos on how to do these cases efficiently. I'll link them up here and in the description. Feel free to check them out. The finger tricks are also a really important factor when it comes to how quickly you can do F2L. So for example, we have the orange and blue case here, and if you regrip every time to do this case, like this, then that regrip takes a lot of time. And in fact, this case can be done without a regrip if you know some special finger tricks. So for example, in this case, we could keep both thumbs at the front and do this pinch move up here. That takes the edge out, pairs them up, and does it without any regrips. And in this case, we can insert into the back without any regrips either, like this. So alternating between your left hand and your right hand will help you save regrips as well. So the general rule for F2L is that you want to have both your thumbs on the front layer before and after each F2L case. So I'm going to show you an example. It's this example again, and this is a pretty long case, but just to give an example, notice how my thumbs are both on the front layer before the F2L pair. Now I'm going to solve this F2L pair and notice where my thumbs end up after I solve it. So as you can see, this F2L pair is solved and both my thumbs ended up on the front layer. So that's really important for F2L, because if your thumbs remain on the front, you won't have to regrip ever during F2L. So the only time you should have to regrip during F2L is if you have a back slot insert. So I'm going to show an example, for example this pair going into the diagonal slot, so I can pair them up like this, and notice here I'll have to insert this into the back. So I can do it without a regrip using this finger trick here, but in an actual solve you'll find that this push with the U is actually pretty slow, and so what I would do instead is to just regrip like this to insert into the back, and this should be the only time when you have to regrip during F2L. But with that being said, there are minor optimizations you can do to F2L cases that can reduce the number of regrips you have to do. So for example, this case here, it's the same as the previous case. So once again, I'll pair them up in the standard way. And here, instead of just putting it at the back and regripping to insert, what I could do, since after I pair them up, they just end up in this position, what I could do is from here, insert with a U2. And U2 inserts for back slots are really good because they don't require any regrips. Notice how my thumbs stay at the front after the insert. So to be fast at advanced F2L, you also have to be able to recognize cases quickly. So for example, this red and blue pair, I know the corners here and edges here. So what a lot of people do is they move it on top of each other like this and realize what case it is, and then they end up just moving the corner back to pair them up like this. And really, you should be able to recognize this case from this position and go straight into how they're meant to be paired up. And so you don't have any redundant U moves during F2L. So for advanced F2L, you not only want to be able to recognize cases quickly, but you also want to have an idea of how these pieces will interact with each other. So for example, if I insert the orange and green pair, I notice that the orange and blue pair won't be disturbed. In fact, it'll just move over into this position at the back. So I have in my mind that if I insert this pair, these will be set up at the back. So I know this case, so I can just do an L prime U2 L, and that should set these up as an F12 pair ready to insert. So as an example, so if I insert this pair, I know that this pair is going to end up at the back, so I can go straight into pairing them up and go into the insert into the back as well. So recognizing cases quickly also involve recognizing cases from the back angle. So in this case, I have most of F12 solved, and I can deduce that this would be my last corner and last edge. And so instead of looking at the back or even rotating to check whether or not this is a paired case, in fact rotating would be a pretty bad habit because now it's a different F12 case. So I could pair them up like this, but if I could recognize it from this angle, then I wouldn't have to rotate, and I can just go straight into inserting this F12 pair into the back. So here's another example of how important it is to be able to recognize F2L cases from the back angle. So in this case, I see the red and green corner, and I'm looking for its corresponding edge. So with deduction, I can deduce that it's this edge because this one's got orange on it, which is not right, and this one's got yellow on it, so it can't be this one, and it's not any of the edges that I can see, so it has to be this one. But what's most commonly done in this case is to just rotate and have this F12 pair. Now the problem with that is that when you insert or when you pair the pairs up, then you'll have to rotate again to insert, and that's not really efficient at all. Instead, if you're able to recognize what case this is, even from the back angle, then you can pair them up in a way so that when you insert, it's rotationless as well, and that makes the whole sequence of moves a lot faster. So for last layer algorithms, the general rule is to rely mostly on your dominant hand, but in F2L it is quite the opposite, and you want to be able to perform F2L cases equally as good with both your left and your right hand. So in this case, I see the orange and blue F2L pair, and what most people will do if they're right hand dominant is they'll rotate and have this case in which you can just use your right hand for it. So the problem with setting up this F2L case for our right hand is that before we even start the case, we have to rotate to set it up on our right side. If we get the case from this angle, for instance, then that's quite inefficient to have to rotate before the F2L pair. So what we could do instead is that we could use our left hand for it, and in that case we don't have to rotate at the start. We can just pair the pair up like this and insert like this with our left hand, and that does reduce the rotation at the start and does make the F2L pair slightly faster to do. So this is another example of when you could use your left hand during F2L, is if you have this corner and this edge here. So what most people would likely do in this case is to rotate so that you have this pair, and then once again you could use your right hand for this case, so like this. But once again, there's really no need to rotate in this case because we could just simply use our left hand. So once again, for this case, what we could do here is to do a sledgehammer with our left hand, and in this case, we could solve this F2L pair without a rotation, which makes it a lot faster. So the last tip for advanced F2L is something that I've been mentioning all along, and that is to reduce cube rotations. So for this F2L pair, what I used to do when I first learnt this F2L pair is to move it over here. So I'll rotate first to pair the F2L pair up like this, and then I'll have to rotate back to insert. and notice how there were 2 cube rotations for the F2L pair, which is quite inefficient. So instead, for this F2L pair, there's a nice rotationless way to solve this into the front slot, and it goes like this. So insert the edge, move the corner back over, and then pair this F2L pair up like this. And so that saves me 2 rotations, which makes this F2L pair a lot faster to do. So the general rule for F2L rotations is that you should never have to rotate more than once for each F2L pair. So if you do the quick math, then 4 F2L pairs per solve, less than 1 rotation for every F2L pair, which means that you should have less than 4 rotations in every solve. Now if you have more than 4 rotations, then most likely you're not doing the F2L pairs the most efficient way, because your cross and last layer should be rotationless anyway. So 4 rotations for each solve is what you should be aiming for. Now I just have a hand scramble that I've just done the cross on, and so in this case I'll just show you an example of how I would approach F2L here and count the number of rotations I'll do during F2L. So this is actually a pretty bad scramble because all the corners are inserted, but let's give this a go. So I see the red and blue pair, so I'll do that first. So I'll pair them up. I'll have to rotate to insert, so that's 1 rotation there. Insert, and next I see the red and green, so I could go straight into that. So I'll pair them up like this, and then I'll have to rotate, so that's 2 rotations. Insert, and now I see the orange and green pair, so once again I'll have to rotate, so 3 rotations, going into this pair. And then finally this pair, the orange and blue pair, which I can do without a rotation. So that solve was only 3 rotations long because OLO and PLO do not require any rotations. So before I end this video off, I want to briefly mention look ahead. So look ahead is something that's really important for advanced F2L, but it's not something that you want to learn too early. You want to be familiar with all the advanced F2L cases first and then approach look ahead. So that's it for this video. I hope you guys learned something. Thanks for watching, and I'll see you next time.